Hello, this is the part 4 of the core learning unit of the educational module IoT Business Value. For a company that wants to involve IoT in their business world, 3 categories of challenges exist to overcome. The 3 categories are technology, business, and society. This part covers all the technologies needed to make IoT systems function smoothly as a standalone solution or as part of existing systems. Technological challenges include security, connectivity, compatibility, and longevity, standards and intelligent analysis and actions. The first technological challenges is security. The more IoT becomes part of our lives, the more important is to deal with security. IoT has turned into a serious security concern, drawing the attention of many tech companies and government agencies worldwide. As the IoT things in our lives grow, the security is no longer about the protection of sensitive information or assets, but will be about our own lives and health that can be a target for hack attacks. The most common reasons for the insecurity in the IoT world is the golden rush state of a company. In this state, a company will seek to dish out the next innovative connected gadget before the competitors will. As a result, the functionality becomes the main focus and security takes a backseat. The second technological challenge is connectivity. The main task of IoT is the communication between sensors, the environment, and gateways. All these devices need to be connected, so the biggest challenge arises from the task of connecting all these devices. This will also define the structure of current communication models as well as their underlying technologies. The current technology can handle from tens, hundreds, even thousands devices, but when networks grow to join billions or more devices, bottlenecks will occur. Such centralized systems will require huge investments and maintenance to handle larger amount of information. As a result, the need of decentralized IoT network arises. The third technological challenge involves compatibility and longevity issues. The need of extra hardware and software will arise due to the growing nature of IoT in different directions. Other compatibility issues stand from non-unified cloud services, lack of standardized machine-to-machine protocols, and diversities in firmware and operating systems among IoT devices. Except of the compatibility issues of IoT devices, another state that need attention is the need of IoT devices to live more. The lifetime of IoT devices tend to be longer than the generic computing devices. Additionally, the IoT devices need to live longer and at the same time be able to function even if their manufacturer runs out of service. The fourth technological challenge is standards. Technology standards include network protocols, communication protocols, and data aggregation standards. All together create the activity of handling, processing, and storing data that are collected from the sensors. From this aggregation, the value of data is increased, that increases the scale, the scope, and the frequency of data available for analysis. The challenges facing the adoption of standards within IoT can be divided into 2 main categories based data they are process. The first category is standards for handling unstructured data. Data that are structured can be stored into relational databases and queried through SQL. On the other hand, unstructured data are stored in different types of NoSQL database that have no standard querying approach to be able to request the data. The second category is technical skills to leverage newer aggregation tools. Companies can be good in leveraging big data tools but often face a shortage of talent to plan, execute, and maintain systems. The last technological challenge is intelligent analysis and actions. The last stage of IoT implementation is to extract insights from data for analysis. The analysis is driven by cognitive technologies and the accompanying models that facilitate the use of cognitive technologies. The second phase of this stage is intelligent actions. They can be expressed as machine-to-machine and machine-to-human interfaces. Examples of this are all the advancement in UI and UX technologies. Factors that drive adoption: intelligent analytics within the IoT are: artificial intelligence models can be improved with large data sets that are more readily available than ever before, thanks to the lower storage. Real-time data processing and analysis: analytics tools enable processing and analysis of data on a real-time or a near real-time basis, driving timely decision-making and action. Growth in crowdsourcing and open-source analytics software: cloud-based crowdsourcing services are leading to new algorithms and improvements in existing ones at an unprecedented rate. Challenges facing the adaptations of intelligent analytics within IoT are the following: inaccurate analysis due to flaws in the data/model. A lack of data or presence of outliers may lead to false positives or false negatives, thus exposing various algorithmic limitations. Legacy systems' ability to analyze unstructured data: legacy systems are well suited to handle structured data, however most IoT business interactions generate unstructured data. Legacy systems' ability to manage real-time data: traditional analytics software generally works on batch-oriented processing, wherein all the data are loaded in batch and then analyzed. Factors driving adoption of intelligent actions within the IoT are the following: lower machine prices, improved machine functionality, deep learning tools, machines influencing human actions through behavioral science rationale. Challenges facing the adoption of intelligent actions within IoT are the following: information security and privacy, machine interoperability, machines' actions in unpredictable situations, slow adoption of new technologies, mean reverting human behaviors. A business model for IoT must be sound and solid to support a successful business. A successful IoT business model is a big motivation for starting, investing in and operating any business. It is important that the chosen model satisfies all the requirements of all kinds of e-commerce, vertical markets, horizontal market and consumer markets. It is worth mentioning that this category is always the victim of regulatory and legal scrutiny. The most successful at monetizing a large portion of the IoT value are end-to-end solution providers that operate in vertical industries and deliver services using cloud analytics. While many IoT applications may attract modest revenue, some can attract more. For some of the existing communication infrastructure, the operators have the potential to open up a significant source of new revenue using IoT technologies. IoT can be divided into three categories based on the usage and client base. Consumer IoT includes the connected devices. Commercial IoT includes things like inventory controls, device trackers, and connected medical devices. Industrial IoT involves all connected industrial devices and systems. Consumer IoT include connected devices, like wearables, smart homes, and personal monitoring devices. The devices and services are oriented towards individual users or families. These devices are likely to have a shelf life measured in months or years, with new versions quickly replacing older products on store shelves. As a result, the device lifetime may be for many years, but replacement rather than maintenance or upgrade is the normal. So, the hardware tends to be designed for low cost and limited lifetime and maintenance. Many devices can be unique per consumer, although some of them may require more than one. For example, a large house will need multiple thermostats, or for smart lighting, each light bulb is considered a unique device. The limitation of the amount of devices used tends to simplify the management interface software of the user for many reasons that also include security. From the point of view of the user, the collection of the devices and their management is isolated to that user and to the user's family. A consumer IoT device example is the Amazon Echo voice control system. This device is a smart gadget by Amazon for home use and consists of the hardware Echo and the software Alexa. Echo is an expertly tuned speaker with Wi-Fi and Bluetooth connectivity. Alexa is the software part of the Echo and is cloud-based, that consists the brain of Echo. Some of the features of Amazon Echo are: it plays all your music from every music app and more using just your voice. The room is filled with immersive, 360-degree omnidirectional audio. It can call or message anyone hands-free with your device. It can hear you from across the room with far-field voice recognition, even while music is playing. It can answer questions, read the news, reports traffic and weather, read audiobooks, give info on local businesses, provide sports scores and schedules, control Amazon Video on Fire TV, and more by using the Alexa voice service. It can also control lights, fans, TVs, switches, thermostats, garage doors, sprinklers, locks, and more with compatible connected devices. Commercial IoT can be categorized between consumer and industrial IoT because it shares aspects from both categories. Inventory controls, device trackers, and connected medical devices are included as part of the commercial IoT. The difference of commercial IoT with the other two aspects is that commercial IoT resides at the company or organization level. A commercial IoT platform example is Verdigris Einstein system. Verdigris is an artificial intelligence company and Einstein is a next-generation IoT smart sensor and metering solution. The goal is to hook it into existing building power infrastructure and provide smart metering as well as monitoring for minimizing power consumption in large commercial buildings. The Einstein system is easily installed and shows the energy usage of the building per panel or device. It is easy to find what to do to reduce operating costs and make the changes needed. With the use of this technology, alerts can be provided to reduce peak demand based on forecasted energy use or continuously monitor equipment for anomalous behavior. Each Einstein sensor streams wirelessly millions of samples per second from the facility's electrical panel to the cloud that it is connected. Then, the electrical fingerprints are analyzed so that automatically notifications are sent about optimizing the building control, predict future breakdowns and critical notifications about energy usage. The results of energy consumption and prediction data can be found into mobile apps and web dashboards, provided by the Verdigris AI software and smart sensors. Emails with weekly reports are sent with energy statistics and measure progress. Industrial IoT, IIoT, solutions target existing automated industrial systems, which at most of the time may be older and the level of sensors is based on what was available. In other words, it involves all connected industrial systems and devices. The sensors are used to provide sufficient information to control the industrial process. It is also possible to track the status of components or even provide supplemental information about system wear and tear to anticipate maintenance requirements. IIoT solutions use more gateways. By using more gateways, not only more planning is required, but also more processing ability is ultimately provided. Additionally, more independent operation is enabled with the probability of distributing information locally. The deployment of an IIoT solution will take longer due to the customization involved in the systems. For this reason, the developers will usually require more support and create more integration solutions. The use of cloud type of integration is impractical due to security, latency, and application issues that surround IIoT solutions. IIoT equipment tend to have more demanding requirements, very long-term support and rugged specifications. Nexeed Track and Trace is a Logistics 4.0 solution for asset and material tracking that digitizes the flow of material from the supplier to the customer. In other words, Nexeed Track and Trace is a digital travel log in the cloud. This solution enables the freight to record a digital travel diary that shares regularly its current location and status to the cloud. This holistic logistics solution can not only write the freight's own digital logbook, but also the freight transmits at each station along the route its present location and status, which are simultaneously sent to the cloud at regular intervals. For example, a scheduler can view at any time the location of the freight and predict if it can be expected to arrive in time. Additionally, except of the location, the freight transmits data relating to temperature, vibration, and humidity. Based on this metrics, the logistician knows right away if conditions are not right for the packages. This solution can avoid deviations such as delays, that frequently cannot be detected early enough, especially in the case of long supply chains. Nexceed Track and Trace makes it possible to depict complete transport processes with the use of the appropriate IoT devices, such as wireless sensors, RFID tags and gateways. Sensors are linked to the transported goods or containers, which are then digitally mapped in the system. The logistics processes are automated and optimized at the cloud, where the generated data is transmitted through the gateway in near real time. Thus, logistic objects and assets can be identified and located at any time. To understand IoT from the perspective of customers and regulator is not an easy task, for the following reasons. The requirements and demands of customers are changing constantly. New users and new devices grow and are being developed dangerously fast. It is expensive and takes time as well as resources to invent and reintegrate must-have features. The IoT technology users expand and change. Consumer confidence, the desire of consumers to purchase connected products can be dent based on each of these problems and will prevent the IoT from fulfill its true potential. Lack of understanding or education by consumers for the IoT device's security cannot help in improving privacy. The IoT applications pose a wide range of challenges and questions from a regulatory and legal perspective that need to be considered. The development of IoT devices can create two cases: either the IoT devices create new legal, regulatory situations and concerns over civil rights that did not exist prior, or the devices amplify legal issues that already existed. It is worth mentioning that the technology is advancing much more rapidly than the associated policy and regulatory environments. The unique privacy challenges created by IoT may go beyond the data privacy issue that currently exists. It is critical to address these challenges because they have implications on basic rights and the ability to trust the Internet as well as the devices that connect to it. IoT devices are able to track, monitor, recognize voices, and altogether collect data that are stored to a cloud service for processing that most of the times include a third party. The legal and regulatory challenges are exposes form the collection process of these information and face data protection and privacy laws. The currency of IoT appears to be data. However, there is a big lack of transparency that include who has access to data as well as how those data are used in developing products or services and sold to advertisers or third parties. The need arises for guidance based on the retention, use, and security of the data, like metadata. This is the end of the core learning unit of the module IoT Business Value.